Okay, so today we are doing this problem, maximum product of splitted binary tree. Hmm. It's kind of a, you can say, it could look tricky, but it's simple. So let's see what the problem statement says. He says, like, given a root of a binary tree, okay, obviously you have been given a binary tree, you have to split this binary tree into two parts, obviously, because the question name suggests that you have to split this binary tree into two parts such that the both parts have some sum, like A and B. So this product of A and B should be maximum. The product of the sum of the subtrees should be maximum. Like what you created, after splitting this return the maximum product of two subtrees. It can be large, so you have to take modulo. So that's what it is. Now, for example, if this is the basically tree given to you, how will you calculate like the maximum product of two splitting? That's what the question is. So that's not a big deal if you find like how to split this. Okay. So how to split this? So it's not like we are going to say, okay, let's find out a particular good point about which I'm going to split it. Okay, that can be a one way because you know the total sum of this tree is 21. So best ways to split is that 10 into 11, because you know the sum of the uh, if you have been given a constant sum, so and you want a constant product, so it's better to like A and B will give you maximum like this product will be maximum if there is a constraint like A and B is equal to some constant. So you know this theorem now, if A and B is equal to constant value, then A into B will be maximum when both A and B are equal, kind of equal, which is equal to A plus B by 2, something like that. But that's not needed over here. You are not gonna calculate like to a good point where, like a good edge about which I will be splitting this tree into two parts. Basically, what we'll be doing, we'll be calculating it for every edge. So basically, we'll be trying and checking, okay, what if I split it around this edge? What if I try to split it around this edge? Something like that. But it's not like we are going edge by edge. We are going in DFS manner, first of all, starting from one. What if I split this node tree like based on one? So there is no way of splitting. It's basically splitting this complete tree into one part, and other part should be zero, right? And then the next thing you will be calling on left part. So left will be saying what is the sum under you. Sum under left part is equal to 2 plus 4 plus 5, that's 11. And the remaining part, sum you need to you don't need to calculate. You can just ask by having 21 minus this part, 11 is equal to 10. So that's the second part. So you will do a multiplication of that, then you will call on 4, then you will call on 5, then you will call on 3, and then you will call on 6. Basically you will be saying what is the sum under you. So 3 will say sum under me is 9, and the remaining sum is equal to 12. So 12 into 9 is equal to what? So that will be my consideration, and at last I want to take the maximum. So it's straightforward problem, but I need to use two functions. So int, sum, or solve, whatever you can call it, this function. Basically here I'm doing all the DFS part. And okay. Okay, why I'm not doing this here only? Because the thing is that I need the total sum of the tree. For first time, I need the total sum. So TOT is equal to sum. I will be calling on root node. So it will give me the total sum of the tree. Then I will again calling on this, sum root, because now the second time, first time I'm calling it for getting complete sum. Okay, complete sum of tree. Sum of complete tree, basically sum of complete tree. Okay, and next time I'm calling it for actual calculation. Okay, for actual calculation of calculating this max answer. So let's see what I'll be doing. Tree node root. Now this function is doing two things. Like this is giving me the complete sum also. Also it's updating my result variable. Like it will be seeing the two numbers which you are getting, like 11 and 10. You will be multiplying them up, and from 3 you will be getting 9 into 12. You will be multiplying them up and taking out the maximum. So int re is equal to maximum. Also over here, if there is, okay, so it's basically working like how the sum function works. So basically if root is null, the return 0, and x is equal to root val. Basically what we do, we call this sum function on root left part. So that's sum under the left part and sum under the right part, and its current node sum. So this is the total sum of that, basically under this node. Now I will be saying like, okay, let's break down about this edge. So if you break down about this edge, so res will be gonna be max of res comma the sum under this node is x, and like the remaining part of the tree is equal to total tot minus this x again, right? So that's about it. That's about it. And you'll be returning basically x only. This is the kind of question, or this is the kind of basically function where we do two things, where we return something, and we store, calculate something. Basically we update something, we update the result variable, but we are also returning the x variable to for next iteration. Next iteration is simple. Basically, it's simple that you have to return x for calculating the sum part now. Because for example, first it will be going on just left, 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 left. It will going to first will be calculating for 4. You will be doing calculation for 4. So root value is equal to 4. Now if you call on some root of left, it will give us 0. So basically now it will return first time for 4, and right is also will give you 0. So now you have x is equal to 4. And res will be calculating as result, which is currently 0, and x is equal to 4 into all the other parts, sum is 17, right? 17 into 4 will be the first candidate you will be going, and then you will be returning x. Basically x is equal to 4, which return you'll return it to 2. So now 2 will say, okay, I'm getting 4 from the start, and then it will call on this. Now you got 4 over here. Now it will call on the right part. So right part will do work for its own, like 5, and then the second candidate you will be getting 5 into something like 16. Then the whole sum will be returned again at this point. So now you will have 2 plus 4 plus 5 is equal to 11, and then you will be getting 11 into 10. Then you will call on 1, then you will call on 3, then you will call on 6. That's how it proceeds. No, basically before 3 6 will be called, like DFS order, it's nothing new. But yeah, that's about it. And tot is also a global variable. Also you need to make mod 1 e9 plus 7. Now it should not go to overflow, so I'm taking long, and that's about it. Last may we'll return res modulo mod, because in question they are saying you have to return it mod. What happened? Res is equal to x into tot minus x. uh val plus sum of root of left, right, and then x is equal to maximum of res into this part, star sum of root. Will be again calling for, oh sorry, not enter tot, because yeah, that is the thing. Basically you have to use this tot variable total sum, which is calculating the sum. That's about it. And it was a mistake, but yeah, no problem. As soon as it get accepted. Yeah, so pretty good efficiency. Okay guys, that's about it. Okay, bye.